Coulomb law. Before discuss the Coulomb law, we discuss about the charges and the forces between the charges. Forces between charges. We know that two like charges, like plus charge, minus charge, minus charge, they are two like charges. They repel each other. When they are repel each other, what is the force that they are repelling each other? Which force that they are repelling each other? That force is called repulsive force. These similar charges are called like charges. Now we discuss the unlike charges. Unlike charges such that plus or minus, they are opposite charges. When they are opposite charges, they are attract each other. Repulsive force, they have attractive force that they are attract each other. In which force they are attract each other? Attractive force between them due to which they are attract each other. This force is called attractive force. So two forces between the charges, repulsive force or attractive force. Now we measure the quantity of this force, how much the force is between the charges, like charges or unlike charges. So question is arise here, how much repulsive or attractive force exists between these two charges. How can you calculate? Coulomb law. Coulomb is successfully explained or calculated the repulsive or attractive force between like and unlike charges. In simple words, we explain the Coulomb law. It calculates the force of attraction or repulsion between two charges. We all know that we measure the mass in kg. Similarly, we measure the charge in coulomb. That was first C. Now consider two charges like plus charges that are static and point charges. Static and point charges. I keep them in vacuum or air. The distance between these charges is R. The size or magnitude of this charge is Q1 and size and magnitude of this charge is Q2. We already know that the force between these two charges is repulsive force. The force between those two charges is repulsive force, but we do not know how much this repulsive force. We calculate it by using the Coulomb law. Coulomb's law states that the force between the two charges is directly proportional to the product of the magnitude of the two charges Q1 and Q2. Secondly, he says that the force between the two charges is inversely proportional to the square of the distance between them. So Coulomb law firstly states that the force is directly proportional product of magnitude of the charges and inversely proportional to the square of the distance between them. Now listen carefully. I combine these two equations, so I get F is directly proportional to the product directly proportional to the Q1 into Q2 upon R square. So after the combine the equation, what we get, force is directly proportional to Q1 into Q2 upon R square. Now I am interested to remove the sign of the proportionality. To do so I have placed a constant. So I write F is equal to K Q1 Q2 upon R square. This is called the Coulomb law, and this K is known as Coulomb constant. Here the value of the K is equal to 1 upon 4 pi epsilon naught. Hence remember that K is actually the property of the medium. Hence we take the medium, that is air or vacuum. So the value of the air of vacuum is the value of air or vacuum is approximately K is equal to 9 into 10 to the power 9 Newton meter square per coulomb square. Now we discuss the dependence of the Coulomb law of Coulomb's law. Coulomb law depend upon these three factors. Force is directly proportional to the product of the charges Q1 and Q2. Second, force is inversely proportional to the square of the distance between them. Third, is depend upon the medium or value of K. Now question is arise, where is Coulomb force acting on charges? So answer is it act along the line joining the center of charges. For example, here we take two charges plus or minus. We join them such that we join the center of the two charges. The force is between them force of attractive. So force is either attractive or repulsive, always act along the line of joining of the center of the charges. Now question is arise, why Coulomb's law is inverse square law. Coulomb law gives the formula that force is inversely proportional to square of the distance. For consider if I increase the distance between the two charges is 2 times, then force is increased 4 times. If we distance increase 2 times, force is increased 2 times. Now if I decrease the distance decrease 3 times. If I increase the distance 2 times, then force is decrease 4 times. If I decrease the distance 3 times, then force increase 9 times. Therefore, we call it is inverse square law. Now question is arise, what is mean by point charge in Coulomb law? The charge should look like a point from a larger distance. So point charges is not equal to not look like a small charges. For example, the stars in the sky not small but look small. Consider two charges Q1 and Q2. This charge at magnitude is Q1, this charge is magnitude is Q2. Q2 experience the force due to Q1 force is Q1 is in this direction. Q1 will exert force on Q2 charge, as a result Q2 display is in this direction. Now I call this force is F21 because it exerts the force on Q2 due to Q1. So we can write F21 is force on Q2 by Q1. We know that due to this force, the charge is displaced in this direction or away from the Q1. So I call this displacement is R12. So it means R12 is displacement from Q1 to Q2. R12 is displacement from Q1 toward Q2 charge. So we have two parameters F21 and R12. Now write this force in vector form. We know that any vector look like F, that is equal to the magnitude and unit vector. We know that the magnitude of the force F is equal to K Q1 into Q2 upon R square into distance R12 unit cap. So here the question is arise, why we write this unit vector R12 instead of F21 unit vector. Here we also write K Q1 into Q2 upon R square into R12 unit vector. Oh, sorry, instead of R12 we write F21. Now let me explain the unit vector. Remember these 2 points about unit vector. What is unit vector? Unit vector that magnitude is equal to 1 and shows direction. So the unit vector So the unit vector of F21 is F21 cap and magnitude is 1. Secondly, similarly, the unit vector of R12 is R12 cap and magnitude is 1. Now listen carefully that F21 unit vector is equal to R12 unit vector because they have same magnitude and same direction. So instead of F21 we can write R12. So what is the equation? F is equal to K Q1 Q2 upon R square R12 unit vector. This is the equation number 1. Now we discuss the second part of the Coulomb law, that is the two charges, one charge that have magnitude Q1, second charge that have magnitude Q2. So Q2 will exert the force on Q1 as a result of this Q1 displaced in this direction. We already know that the force on the charge Q1 experienced due to charge Q2, we call it F12. So we can write F12 is equal to force on Q1 by Q2. Thus, this charge is displaced away from the Q2. We see that R21 is displacement from Q toward Q1. So we can write R21 is equal to displacement from Q2 to Q1. So I will write this equation in vector form. F12 is equal to K Q1 Q into Q2 upon R square into F12 unit vector. We know that the F12 and unit vector and R21 unit vector is equal. So we can write instead of F21 R21. So this is the equation number 2. Now I take the two distance that we get, R12 unit vector and R21 unit vector. Now here the direction of R12 is toward right and direction of R21 is toward left. So we can write here R12 unit vector is equal in magnitude but opposite in direction. This minus sign minus indicate opposite direction. So from the equation 1, so we can put this either the equation 1 and 2. For example, F21 is equal to K Q1 into Q2 upon R square R12 unit vector. Now I put this equation into this equation. So what we get? 21 is equal to K into Q1 Q2 upon R square. R12 is equal to minus R21 unit vector. So bring the minus sign to the first position. So what we get? Minus K Q1 into Q2 upon R square R21 unit vector. So we can see that F12 is also, so we also know that F12 is equal to K Q1 into Q2 upon R square into R21 unit vector. So here we can write F21 is equal to minus, this is equal to F12. So final, so I put it here, final we get F12 is equal to minus F21. So it means that the two charges that are equal in magnitude but opposite in direction. Two charges equal in magnitude but opposite in direction. So Coulomb law in vector form we discuss.